Today's session is AI in finance, demystifying LLMs and data classification. So welcome everyone. Super excited to see our amazing speaker today, Sanjana Raj. She is the CEO and founder of Fortuna. Please make a note of all your questions and share us with in the chat section. We shall discuss it during the Q&A session at the end of today's discussion. A brief introduction to our speaker, Sanjana Raj. She is the founder and CEO of Fortuna, a fintech company which is revolutionizing financial market with the power of AI. Sanjana's tech journey began with successful roles as an individual contributor and software engineer at Sony PlayStation and Jack's Pacific. Leveraging her exceptional knowledge and hands-on experience in AI and machine learning, she aspires to bring transparency to Wall Street and reshape the landscape in fintech space. Okay, Sanjana, I'll hand over the screen session to you. Thank you so much.
Great. Let me tell me if you can see my screen. I believe you might have to stop sharing yours.
Yeah. Are you able to share it now?
Not yet.
Okay, can you try again?
Yeah.
Okay, cool. Thank you so much for joining us, Sanjana, and sharing your knowledge with us.
Yeah. I'm so happy to be here. I'm excited to meet all of you, learn about you guys, and have any questions, have any do you need any help in sample projects? You want to code with me? I'm available anytime. So let's just begin. So that, let me see. I think the sharing stopped. Let me see. I think there is a problem with it.
Okay. Can you try again?
Yeah, I can try again.
Okay. Do let me know if you face any issue.
Yeah. Okay. So this is about finance and LLMs, and this is an emerging tech track. So I kept it as an overview and not too much of a dive deep situation, but I can still go ahead and do that in the next one, or maybe you can contact me later. So this is the agenda. First thing is we're going to go through the introduction of what is an LLM, what's the difference between natural language processing and an LLM, and how can you possibly build your own with respect to financial applications and data classifications. And at the end of it, you can have a sample projects to go home and try it by yourself so you can learn better. So thank you, Poulami, for your introduction. I have been working as a software engineer at Sony PlayStation, Jack Pacific, Thales Avionics. I also serve as a committee member and a peer reviewer for several IEEE AI conference and journals. And I'm also a business mentor for different startups, basically. So it can be anything from fintech to food tech to insurtech, so anything with startups. So let's just dive in. So LLM. What is an LLM? So there's so much buzz about LLM that you might be confused or you might have too much overload of data. So let's just go to what is a language model. So a language model is anything which takes in, it's a type of AI which is trained on like large amounts of data to understand and generate human-like language. So let me give you an example. Suppose you have a pet at home, a pet cat. Let's call him Dobby, if you are Harry Potter fans. So let's call him Dobby. And Dobby listens to you every day. Around lunch, you get up and say, I'm so hungry, I want a pizza. So Dobby keeps listening to you and he keeps mimicking you. Okay. So when Dobby is mimicking you, say, oh, every day he gets up or he or she gets up at lunch at noon. I'm hungry and I want a pizza. And Dobby learns to recognize a pattern and he might complete your sentence as soon as you say, I'm so hungry. And he can say, I want a pizza. This is because Dobby works in a stochastic probability, saying, hey, this is a randomness, and he probably might say pizza. He might not necessarily understand what pizza is, but he thinks this is what you're going to say next. This is the word generation. So imagine Dobby listens to you and your neighbors. Now expand the data. So he's listening to a lot of different people talking about different foods at the same times. So he's like, okay, there's pizza, there's pasta, there's salads, there's burgers, there's different cuisines. Now imagine Dobby listens to an entire city, or he's traveling and he listens to an entire world. So this becomes a large language model. So that is what constitutes an LLM. And instead of a language model, it has multiple thousands and millions and billions of parameters. So when I say parameters, what does it mean? To give you a brief chunk of what a large language model is made of is neural networks. Most of you might know what a neural network is. It basically acts like a copy of your brain. So there's nodes. So there's input nodes and there's an output node, which gives you, in this context, we need to input a particular sentence and expect an output, which is a new generation of the continuation of the sentence. So there are hidden layers in the middle of the neural network, which is in the backend that's happening. And that can be multiple layers, multiple parameters, depends on the vastness and the accuracy of your model. So to avoid your probabilistic approach of randomness and to stochastic behavior, what you need to do is train the model on large amounts of data. So anyone you met might tell you OpenAI is so famous because of ChatGPT, because it trains on such large amounts of massive amounts of data. Anyone might say that, you know what, for your LLM or for your model to function properly, you need a lot of data. So the first key thing for anyone to understand when you're building it, when you're trying to code it, when you're trying to understand it, you need large amounts of data. So that is your basic understanding of an LLM. So use cases. I'm going to concentrate more on the text aspect of it and not the image. Computer vision and image processing and all of that is a separate branch. Right now, LLM is used for summarization, text classification, completion, translation, and question answering. Basically, your chatbot, which can understand you like your BFF. Examples. So examples, you already know OpenAI, which is a GPT model. There's GPT, it started off with 3.3, 3.5 in the early 2021. And then there's GPT-4 right now. And you can have access to it. It's a OpenAI API, and it is paid. And there's Google's Lambda Bard. It's one of the largest. It has a lot of parameters, almost up to I think 120 billion, if I'm not mistaken. Anthropic Claude. It's really smart. The Claude stands out because it's the way of understanding and reasoning and logic and reasoning is very unique. And if you get a chance, you should really try it out. Next one is Megatron, NVIDIA's. This is the largest LLM in the world right now. You know, NVIDIA is always in the news. You know what's happening with NVIDIA, and it's beautiful. The AI chips and the AI, the model behind it is amazing, and it's ever growing, right? So you should check it out. And Meta's Llama. So this is my favorite right now because it's the only open source LLM apart from Hugging Face, but LLM as a whole. So you can actually use Llama without having to pay for it, and you can build your own applications on it, which is really unique because you might not understand the vastness about LLMs for you to pay GPT models, OpenAI. So Meta's Llama is really good. And I'm going to dive deep into what Llama does, which is quite unique to the rest of the GPTs and the LLMs, and it's really interesting. So yeah, so how many of you here know what an NLP is? So natural language processing. You can comment in the chat box, or let me know later. Okay. Okay, so people are commenting. So natural language processing is when you try to make your machine or your model understand your spoken English or your written English. So when you speak, the machine has to understand the natural language. It does not need to be in code. It does not need to be in prompts, which is like quite unique. It doesn't have to be a JSON file. It has to understand what you're saying. So that is natural language processing. So natural language processing has been there from many decades, I feel, because I've been growing up with it. What is NLP? Everyone's using NLP, sentiment analysis, text classification, and all of that. And recently, all you hear is LLM. How are they different? Are they the similar ones? Kind of. And the LLM is a branch of NLP. So to better understand it, here's an example. So natural language processing, natural language understanding, and natural language generation, which is nothing but LLMs or generative AI. So for you to think about it, so let's say you have a sentence, and for you to say, what is the natural language processing? The NLP model understands what you're trying to say, saying, okay, this is a positive word, this is a negative word, this person does not like pizza, this person does not like burgers, and he really prefers going out for a night out, or he wants to stay in and read a book. So understand and categorize and classify that information is what NLP does. Now, NLU, what is NLU? NLU is essentially the same thing, but the understanding capabilities and the future reactions of what after the understanding is, that is what NLU does. So basically, it has the ability to take decisions and actions based off the understanding of the sentence. So suppose you say, you write 2 lines of a sonnet into a GPT model, and then it knows that it needs to uh, continue the sonnet and complete the sonnet. So this it takes automatically because it first recognizes the sonnet, it recognizes that it is a sonnet, and then it continues to generate the rest of the poem or a sonnet. That's what the understanding is. Now, a combination of both of them is what an LLM is or an NLG is. So here's a quick example. If you can go ahead and see this in OpenAI, I believe, you can go ahead and try to think of different prompts to check it out and test it out. Now, first sentence is, after reviewing the data, Jack confirmed that calculations were right. Okay. Now, here, it's very simple, saying right is in terms of correctness of the calculations, and it's not in terms of the direction. Now, after she turned right, she noticed the path leading up to the forest. She means the direction. So this distinguish, like to distinguish both of them, saying right, both are homonyms. So as a model, are you able to do that? Are you able to distinguish both of them? And how are you going to work through it? If you use only LLM without the NLP capabilities or the understanding capabilities, and just as a chat box or a mimicking parrot, this is what's going to happen. The next generation would be, during the meeting, Jack turned right and confidently approved the budget. It doesn't make sense, but the LLM thinks it makes sense because all the words are rightly used, the grammar is good, but the meaning and the understanding behind this is not. So to make it better, to enhance it, use all three in one, and that's how LLMs are trained better, and that's how OpenAI became the sophisticated model compared to the rest of them in 2023, 2022. So if you use everything, it says curious about it. So curiosity. So basically, this is where the NLU comes in, saying, okay, I am curious. Why is there a path leading up? How does it know this is what the emotion that's going to go through this particular person? So generation based on a lot of fine tuning. So she decided to follow it deeper into the woods. Gives another synonym for forest, it takes a decision, processes it, makes it into a positive connotation. So this is what a combination of all three essentially is. Okay. So here, you guys are here for the financial aspect of it. Let's review what the financial data and how it plays in here. So financial data is really key for us because AI in finance has not been explored yet. It's still an emerging field. People are really curious about it. Many startups are going full steam ahead. So what type of financial data are available? So this first thing is stock market. That's the entire industry by itself. So there's a lot of branches that you can divulge in that. And there is compliance industry, there's expenses and all sorts. Let's break it down. So for stock market, let's go into the historical data. So earning statements, P&E ratio, all of those, profit and loss, company financials, 10K, CC filings, 10Q, and all of those. So this is an example. The image right here is an SEC filing for Google for the 2022 year. So yeah, so when you want to invest in Google today, what would you be told to do? If the first thing that anyone tells you to do is look at the company financials. So how do you look it up? You look at SEC filings, earning statements. So when this particular document is around 90 pages, it's not impossible, but you might take some time to understand and go through everything. There's a lot of technical jargon. You might not understand it if you're not an avid trader or a financial analyst. You might be a tech like we are. So we are in tech, we are in retail industry, we are in marketing industry. We don't have the time and the bandwidth to understand a 90-page document. There are your trade boards and all of those who give you a smaller version of what's happening in the earning statement, sure. But if you really want to put in big bucks, you might want to know how the company is working, right? Like what's happening behind the scenes. For that, you need to have a large data model interpreter, right? The second thing is financial news analysis, social media trend detection, all of those. Why is this important? Because I don't know how many of you know, but you know that big thing that happened during the pandemic, the Reddit GameStop phenomena, right? So everyone was obsessed with GameStop. If you don't know, let me give you a context. Everyone is obsessed with GameStop stock because people were like, you know what, this is going almost bankrupt. We have a nostalgic association with it because when we were kids, we used to get games from there. So let's group together as a bunch of retail investors. Let's just buy, and bet against the big Wall Street hedge fund. And what happened is usually you think as a head retail investor, you don't make that much of a difference in your big Wall Street, big bad wolf type of situation. But they did make a difference and they brought GameStop from, I think, $4 to almost $500. So that kind of, threw everyone off. Like what's happening? Who is in charge? Why did they unite? Like what is this? And certain hedge funds lost a lot of money and certain retail investors made a lot of money and it became like next best thing in the fast money. And it did fall later because nothing is on top always. So this opened many people's eyes, saying there's something to do with trend analysis. So what people are talking about in social media makes a difference when you want to invest in certain stocks, right? So people started scraping data from Twitter, Reddit, and all sorts of things. And let me tell you, I also did the same thing. I did scrape it from Twitter. I used Twitter API when it was free. And it was an amazing thing because you get a lot of data from tweets. You do sentiment analysis, saying positive, negative, and then say, hey, there's a lot of positive connotations. They can score them. You can extract the features, and they say, let's just go for these stocks. So Elon Musk tweeted about something, let's just buy Tesla. So this kind of situation. So this entire thing uses text analysis, right? So a lot of data, a lot of text, colloquial sentences, colloquial words, punctuations, and understanding that. So this is a financial data in itself. Another one would be many companies are struggling with compliance. So they don't know if they're in compliance or if they're not, or what does it cost for them to be in compliance, the documents, the regulatory. Each government has their own laws. So compliance and regulatory to understand and emulate what's happening with your company documents and then see if it's in compliance. So basically, there are multiple startups in the past year that's just doing that. So parsing your data, parsing your financial documents, and letting AI do the work for you. Expenses and transactions. I don't know how many of you have heard Mint. So basically, they were the best expense app, which says, go through my credit cards transactions, tell me where I'm spending, and try to categorize them. So when we look at our credit cards, you know that we don't really understand most of the statements because it's kind of the difficult to understand, right? So you don't know if you bought Adidas or if you bought something else altogether, right? So the transactions and the credit card expenses, for you to categorize it and classify them, it makes a lot of difference for you to say where are you spending your money on, and then trim down on that. So that's the whole other ball game. Credit scores and debt, again, it involves user and mathematics correlation. So statistics and user data. So a lot of secure data, bank transactions, bank interactions, encryption, and all of those. So when it comes to financial data, all you need to know is you're working with numbers and statistics as well as people. So to combine both of them, to make them correlate to each other and get out a positive, a good data set is quite difficult, but it's quite easy to get the large amount of it because there's so much data. So let's just see. It might be a lot to go through this, but let's just go one by one. How do you build an LLM? I'm pretty sure each one of you might have thought about it. You like, what is an LLM? How do you build it? So this is a rough derivation from FinGPT architecture, which is really amazing. So FinGPT is a research paper published. It's not yet it's not yet built, but it is a theorized aspect of it where there's multiple, it's not only these applications, there's multiple different applications. You can go ahead on the GitHub and check it out. So this is solely for let me give you an example of what the expenses and classification for expenses would work like if you use this architecture to build your LLM. So for data, let's consider what data you need for you to classify your expenses, right? Credit statements, bank transactions, mortgages, debt, cash transactions, social spending, savings accounts, high yield savings accounts, what's the interest, what's your stock investment returns, dividends, and all sorts of data, right? All your income and your expenses. So you need to gather all these data and pull it into a data lake. And why a data lake and not a data warehouse? Data lake is nothing but a pre-processed unstructured data. You have not yet processed it, and you just have to dump it in there. You can use AWS, um, very easy, kind of cheap if you start off. So yeah, so from data lake, what is the next layer that you hit? Data cleaning and processing, right? The first thing would be cleaning the data. So removing stop words, punctuations, characterizations, multiple things, right? Then you do tokenization. So tokenization, you might be hearing a lot in any machine learning and or LLM situation. Tokenization is where you break down words or sentences into tokens. So each word would become a token and they are independent of each other. So you don't think of a sentence as a whole, you break them down into tokens. Then feature extraction. So to explain feature extraction, let me give you an example. So let's take into stock market, right? The stock market data, you have historical data. There's open, high, close, low, and there's P/E ratio, earnings, volume, market cap, on all of those. So when you look at, let's say, Meta, right? Meta stock, and this all this information that you get, it's available. It's easy to access it. It's so much data. How do you know what feature to target, right? What feature to target so that you get an accurate result of how a stock might perform in the future. Let me explain. You have today Meta is going at, let's say, $150. You want to see if you want to buy it and if you can make a profit. So you have all the historic data in front of you. How do you, what parameters would you pick out of all of these historical data parameters to run your model on to predict your future price of stock? There's multiple, right? There's market cap, open, high, close. What do you do? So for you to extract the important features, saying, okay, this feature will make a difference in me predicting the model. So in predicting the price of the stock. So how do you pick the feature? So this is where the feature extraction and machine learning algorithms come. So for example, random forest is a good algorithm. It has multiple decision trees and it randomly picks one feature and then tests the model with this training data set and then sees if you can live without this feature, how the prediction would be. So elimination and importance. So this is feature extraction. This is just a rough overview. And then there's prompt engineering. Prompt engineering is what LLM is all about. You need to know how you query your model. You can query it the most simplistic way and expect not that much of an accurate response from a GPT. I'm pretty sure every one of you has tried it, has asked your OpenAI chat GPT saying, give me something, and it might not really do what you expect it to. That's because the way you question it or query it is very key. If you want to really be the best LLM person out there, you need to get skills for your prompt engineering, right? The more accurate, the more context you give to your query to the LLM, the better performing response you'll get, right? So it goes through all of this and then goes on the upper layer, which is the GPT layer. So GPTs, Llama, Transformers, RLHF. Let's see what this is. GPT and Llamas are, that they are LLMs. So LLMs constitute of transformers. And let's wait for transformers. We have another slide for it. So RLHF. What is RLHF? So many of you might have heard it. It is reinforcement learning with human feedback. Now, you have a GPT model. I'm pretty sure most of you has used ChatGPT, and every time you get, not every time, but most of the time you get a response. You have a tiny widget that says, how was your response? Was it good, bad, worse, better, whatever, right? It's asking for your feedback on the particular response for your query. Why is it doing that? Because a GPT model runs and learns from human feedback. So if it doesn't, it just goes ahead saying, I'm perfectly right. I'm going to keep giving these answers to everyone because it's not feasible, it's not accurate. So this reinforcement learning. So every time you give a feedback to it, it learns from it saying, okay, this might be better. So let me try to make it better. So it's basically like giving your pet treats, saying, oh, you guessed that I wanted to eat pizza. Here you go. This kind of scenario. So the cat, Dobby, would like to say, okay, yeah, maybe I'm right. I'm going to get another treat if I mimic or if I generate the next word properly. This is essentially what RLHF is. Transformers will go to it. And yeah, oh yeah, I missed stemming and lemmatization. So during your cleaning process, right? What is stemming? So you try to bring down the word to the root or the stem of the word. So for example, there are two words in the same sentence, historical and history. So try to make, you can't have redundancy, right? Redundancy you want to avoid when you want to process your data. So you want to stem that down into say history. It's not historical, it's not history, but in stemming, it might not really say HISTORY. It might just say HISTO or TORI because it's just stemming it down. Lemmatization takes longer and it's more better because it's trying to give out the immediate logical answer of the stem. So it actually says history like goes, going, and gone. The stem of it is go, right? So it can understand better and make it faster. That is stemming and lemmatization. So Bloomberg GPT and FinGPT. So Bloomberg GPT is the only financial GPT out there by Bloomberg. It's not accessible to us because they have been training this based on all the data that they have used for Bloomberg Terminal. And it's quite expensive. It's quite um, difficult to do this because fine-tuning takes a lot of processing power, and they've had this data of Bloomberg terminals from I think history, like ages, right? So they've put all of that data into this GPT, and people who have access to Bloomberg terminal have access to this. It's quite great actually if you want to really be an investor, or if you want to work in Wall Street. If you get to use this, you don't have to go through that abundance of data saying what happened on this particular day for this particular stock. At this dip, what did I do, right? The GPT tells everything to you. So that's a great thing. And FinGPT is the research paper that's been published. People are working on it. People are building on it. You can go ahead and build too using their GitHub. It's not easy per se, but you can understand where it's going if you dive deep and understand the rest of the aspects behind it. So you have this your GPT and Llama and transformers, and above it is where your applications stand. You can have your expense trackers, credit score optimization, application, stock market analysis, like we spoke about, 401k, IRA, Genie. So you can guess how much would you put in your 401k or your retirement savings, and say, what would I get at the age of whatever. What's the best efficient investment strategy? And loan assessment. So you don't need to go through multiple bankers. You don't need to get rejected. You don't need to do all of those, or you might not be thrown preposterous interest rates. So loan assessment is also a good application. So yeah, so let's go into transformers. Transformers, in a simple word, is basically multiple neural networks. That's it. It's not as complicated as you think it is. So a transformer is if you have encoders and decoders coupled together is a transformer. And each transformer, so there are 6 encoders, let's say. There's 6 encoders and 6 decoders. That's a small transformer. For an LLM, around 90 to 100 encoders and 90 to 100 decoders are there. So that's large. So that's what they mean by large language models. So transformers, let's just break it down into the components of it, and it's quite simple. So you have input layers before you enter the encoder layer. You have input layers where you give in a sentence. At the output layer, after the decoder, you expect the next word in the sentence. The chicken is crossing the road, and you expect the next word. Now, for here you can see input embedding and output embedding. We can go through that in the next slide, what exactly embedding is. To give you just a one-word response is, embedding is converting your text into numbers, because you need to put that into your encoder. So text into numbers, just think text into numbers. So there are 2 main components inside a transformer. There's feed forward and there's attention, multi-head attention. So encoders usually have 2 attention, and decoders usually have 2 attention, and encoders usually have 1 attention. So what does that mean? How many of you have heard the movie called Mean Girls, right? There's Mean Girls, there's Shawshank Redemption, right? Everyone knows Shawshank Redemption, right? So the probability of you attaching any other different word apart from redemption after Shawshank, right? After Shawshank, most probably you will say redemption. There's not many choices that you have after Shawshank. It's not a common word. And everyone associates that with that particular movie. So if you say Shawshank, I'll say redemption. The probability is very high. So looking at that, the feed forward network right here, the feed forward network, what it says, if you input Shawshank, it knows what the probability of redemption is. It passes it forward to the next encoder and the next decoder, and the output would be redemption because it knows what to expect. Now, what is the attention, multi-head attention or anything like that? So let's think of a simple sentence. For example, the cat did not drag the string, it was far, right? The cat did not drag the string, it was far. Now, When you input the sentence, what does the it symbolize? Is it the string? Is it the cat? The cat was far? Was the string far? You don't know. You as a human might know. The model might get confused as to what the it was. You're not completely clear. To channel your attention on which word to concentrate and to channel where do you understand and where do you put this in is what the multi-head attention does. So there are two components of a transformer. There's feed forward, there's multi-head attention. One is probabilistic, high probabilistic words goes directly through feed forward. Second one is you need to understand it better to get the idea of where the attention has to lie in a particular sentence. And then it goes through the multi-head attention. Everything else is just a lot of in-depth encoding and decoding capabilities. You might not need to learn that immediately. You can go deep later. So this is a transformer. So transformer is multiple neural networks coupled together, and each encoder decoder, so 90 to 100 layers of encoders and decoders for an LLM. And each of these encoders have two components, and you have embedding. So basically, you're converting text into numbers, feeding that into your transformers, and then getting a number and then reconverting that into text. Okay. So I told you I'll talk about Meta's Llama. So why is Meta's Llama so unique compared to GPT? And why many people say it's better? Because if you, LLM has two main challenges. One is hallucinations and training data is out of date. So when you ask anything to ChatGPT after Jan 2022, right here, it does not know because it's been trained on the old data. Hallucinations. What does that mean? If your model does not know the answer, it's going to assume and guess and give out an answer at the end of the day. It's not going to say, I don't know. It's going to say a wrong answer, right? So if I ask, has any space agency been to the South Pole? There has been last year, but it says, as far as my knowledge goes, there is no data. So it doesn't say, I don't know. It says no space agency based on the last data trained. So hallucinations is not only this tiny. So when you think of certain mathematical calculations, so earlier on, the same GPT would give out 2 plus 2 would be 5. So it doesn't make sense. But it's just because it's not been trained on the mathematical calculations, it just spits out an answer. So you need to avoid hallucination. To avoid that, Meta introduced RAG, Retrieval Augmented Generation. So what is it? It combines an information retrieval component with a text generator model to address knowledge-intensive tasks. Its internal knowledge can be modified efficiently without needing to retrain the entire model. If you know anything about retraining a model, it's very expensive. It's very time consuming. So when you want to retrain a model, you have a set of data that's fed into the model. You have trained it, you have training data set, testing data set, validation set, and all of those. And then when it comes out and you're not that happy with it, for you to retrain it, it takes again a lot of data, right? So to avoid that, RAG was invented. What is RAG? Let's just dive deep. So you are a user querying into the embedding model. Now, what is an embedded model? Like I said before, you need to convert text into numbers. If you directly input into an LLM, it's going to give out a response with hallucinations, might give out, and it might be out of date because it's not been trained up to date. If you ask what is let's say let me give you an example. What are the moons of how many moons does Saturn have, right? You might think you know the answer. GPT might be trained on maybe last month's data. Maybe you have a really sophisticated model. It's been trained on last month's data, and then it spits out maybe 182. If I'm not wrong, I might be wrong. So 182 moons. But each day, almost each day, NASA and our amazing scientists discover more moons, and it's an ever-changing process. So if it would have actually gone to the internet and seen like, hey, what's happening? How many moons? And then I'm going to retrieve it for you, it would have avoided this hallucination. So essentially, this is what RAG is doing. So you query into an embedding model where you put in your query and convert that into numbers and vectors. You divide it into vectors and matrices for efficiency. Move that over to your vector DB. You have a database for all of these queries, which is characterized into vectors. And from there, so you data, and what I mean by database is you have a database of the most up-to-date information, or you're connecting to the internet and gathering that data and putting it into the database. So either which way, you're going to the nearest source. You need to check your data sources. So you're going to the nearest source, you're going to see what's happening, you're going to query that and then put it inside a database. Or you have a data collection system already in place, so you go into the database. So you enter the DB, and from there you retrieve the context. So context is, what are you talking about? I want to know about the moons of Saturn as of yesterday or as of today. So you retrieve that and then you feed that into the LLM. And now the LLM knows the data source. It knows where the data is coming from, as well as what is the latest one. And it doesn't have to guess or hallucinate. And then it gives out a response. So this is quite unique for Meta's LLM. And this is why people say, Llama is really responsive, is really logical and reasoning capabilities, is really human-like. It understands what you need. So this is the future of LLM. OpenAI would be building it in the background. You might be wondering, how do I build it, right? How do I do this? It's so complicated with respect to code. Not necessarily. So before that, let me break down the data classification after RAG. So you have your data. You have put that query into your LLM saying, okay, listen, I know what I want. I'm going to get the output or the response. How do you classify your data, right? So you have so much data, you have to pick a machine learning algorithm. Like I showed you here, for feature extraction, you used random forest. I gave you an example of random forest. So this is essentially what you are picking here. You have SVM, which is support vector machine, which is a positive, negative, neutral probability, right? It uses on non-linear data. You have tweets, right? You break it down into tweet ID, tweet description, and user ID. And user ID is where your database connection is, schematic relationship. A tweet description and tweet ID is unique. Description is a text. Break the text down into tokens. Feed that into your SVM. Categorize it into positive, negative, and neutral. Because it's not a linear data. You have multiple parameters. Random forest. What's a random forest algorithm? I'm just giving you an overview. You can dive deep later on, or you can just ping me and I'm going to give you more details. Random forest is where you have multiple decision trees and you pick the best case scenario after deciding everything. So I'm pretty sure everyone knows what a decision tree is, yes or no prompts, and then it goes through that. Like we described here, feature extraction, feature importance. And for logistic regression. So logistic regression is for linear data. It's better than your random forest because there's less noise. And BERT. BERT is bidirectional encoder representation and from transformers, is basically working as a transformer, right? Bidirectional, it's a transformer, it's the next LLM. So this was developed before all the buzzwords of LLM started. So these are the data classification that you can go about. So like I said, how do I build it? How do I start off with it? So you can finish this talk. You can go and learn about it. First thing you would do is, I'm going to give you a sample homework example. build an expense classifier. Fairly simple. You can get the data. You don't need to use your own data for security reasons. You can get your data from Kaggle or any other data set. You can create your own data set, a CSV file of where you would spend uh, basically Costco or shopping, beauty, Sephora, whatever, right? You create the entire data set or you get it and you use SVM for, and because it's not linear, it's a lot of text and it has numerical values as well. So let's use SVM. It's quite easy to use the SVM library. So beginner friendly. And Hugging Face library. Hugging Face library is where you can access your GPT-2 tokenizer. It's really, really amazing. You can start off with it and it's very beginner friendly because it gives you prompts to use, how do you use it every step. And the documentation is extensive. You can learn a lot from it. So Hugging Face library, create an expense classifier using SVM. And I urge you to use RAG because Hugging Face will allow you to. You're not using OpenAI. So how do I do that? So I've given you the basic libraries that you can start off with. So first would be Torch for tensor Torch, right? So tensor computation, PyTorch. So that's where you need to first import. Next would be the NumPy for numeric calculations. The main thing here to concentrate on are transformers. Transformers for GPT tokenizer, which is specific to the GPT-2 model and is provided by Hugging Face. It's a pre-trained generative model. So it's already an LLM that is trained. So you don't need to worry about creating your own because that takes a lot of time and processing power. GPT-2 for sequence classification. That is a version which is for sequences. So if you have multiple runs for a grocery, it classifies your sequence. Label encoder. Label encoder is used for, encoding, right? We want to convert text into numbers. And vectorizer is again, it's already a library from ScienceKit, scikit-learn. If you've been using it, you'll know that. Raw document into a matrix. So why is it a matrix and why not just numbers? Because matrix is fast, vectors, matrices are faster. And Python and Jupyter Notebook for you. You don't even need a VS Code or you don't need a compiler or whatever. You can just use Jupyter Notebook and it's really fun to build this out. And after that, you can add UI and you can make it a dashboard. You can make it your personal things. You can give it to your friends. So I need you to go ahead and do this, and that's how you can learn. I am a big believer of let me learn this and do the practical approach, and then maybe I can understand. These are the resources. Olama. So Olama is really amazing. All you need to do if you have a Mac or Linux, download it. It gives you prompt. The main key thing about Llama is you don't need an internet connection. It goes on your local machine. You don't need to worry that I'm giving out data to some random GPT model. It's on your machine. It's on your local computer. You don't need a internet connection. You go through your terminal and you do your things. You can train it. You can build it. You can do whatever you want. It's amazing. And if you are on Windows, you just need to, it's again simple, you don't need to download, you need to run it and an exe file and all that, but it's not too complicated at all. If you really like OpenAI, that's an amazing GPT-4's capabilities are vast. You have to pay for it based on the prompt tokens. But I would say go ahead with Llama for now. Vectorizer, like we said, is your conversion. And Hugging Face is amazing for your OpenAI. If you want to use OpenAI GPT as a fine-tuning model. So yeah, connect with me on LinkedIn if you have any questions. That's my website for the company. If you have any questions, I'll be happy to answer. If you need to contact me later and then, want to work with the how to code better or how do you build an LLM or whatever, I'm happy to help. So yeah.
Wow, that was a quite an informative session. Thank you, Sanjana.
Mhm.
Uh, Let me see if we have any questions in the chat. Hmm. I see few messages. Tina View, she has completed a project using NLP to distill information from Amazon reviews. That's great, Tina. And Dolores, she was like saying that social media does affect stock market, how it impacts the buying and selling of like decisions of stock. So yeah, that's correct.
Yeah. Yep.
And
Uh,
I don't see any questions, but yeah,
okay.
feel free to reach out to Sanjana or anyone from our like Women Who Code community. We can help you. Thank you so
Yeah.
much.
Yeah. Thank you.
Bye.
Bye.